So, last day, we started day 2, was two-step equations. That means on the side of the letter, there are two numbers you need to get rid of. And we said typically get rid of the adding and subtracting one first, then get rid of the multiplying and dividing one. And so today, we're going to do word problems and some trickier ones of these. Right? Also, I'll highlight some of the spots where maybe students kind of make mistakes with these. So let's start off with, on the back page here, let's go look at, not that one, but let's look at maybe the one over next to it, this one here. Okay. So, go through our steps. It doesn't matter if the x is on the left side or the right side. Remember? You're covering up the side that doesn't have the x. Do you need it in there? Yeah. All right. Okay. So you cover up that side. So you're covering up the left side this time. And we have that 5. And we have that 4 sitting there. Which number do we get rid of first? The 5 or the 4? Right? We cover this up, right? And we want to try to get rid of the one that's adding or subtracting. Right? So is it the 5 or the 4 we try to get rid of first? Anybody? No, it's the 5. Right? Because the 4 is attached. Go for the one that's not attached to the letter. So, because that's 4 times x, right? So the 5, when we're adding and subtracting, our goal is to make 0. Do we go plus 5 or do we go minus 5? Minus. The goal is to make 0, right? If we went on plus 5, positive 5 and plus 5 makes 10. So you got to be careful. Don't pay attention to this sign. You got to pay attention to the sign in front of the 5. It's an imaginary little plus. So if you go minus 5 on this side, you have to do a minus 5 on that side. That's what makes it tricky. It's this sign over here. So now, these 5s go away because that makes 0. What do we write down on the left side? Reese?
Divided by -4?
No.
Oh, left side.
Left side, we write down 2 minus 5, which is?
That's -3.
-3. And what do we write down on the right-hand side? Minus 4x. So, careful that you don't forget to bring this minus sign down. Right? This belongs to the number after it. So when we cancel out this 5, we did not cancel out this sign here. So bring that 4 down, that subtraction sign now down here becomes a negative sign. Okay? So now, cover up this side. We want to get rid of that 4. It is 4 times x. So opposite of timesing, right, is dividing. So we have to divide by not just 4, but -4. You want the negative side to disappear. You divide this side by -4. So those go away. You're left with the x here, just happens to be on the other side. And what do we have on the other side? Right? 3/4. The two negative signs cancel each other out because two negatives make a positive. So we jumped off to a really hard question right off the bat. All right? But the steps are still the same. And the key thing is just to pay attention to those signs. That's what makes it trickier. All right. Okay. Let's do this one. I think this one's a little bit easier. Split at the equal sign. All right. Cover up the side that doesn't have a letter. 6 or 5. Which one do we get rid of first? 6. The one not attached to the letter. Do we go plus 6 or minus 6? Plus, because your goal is to make zeros. Plus 6 here, plus 6 on the other side. Those go away. 7 plus 6, 13. And what do we write down on the right-hand side? Jacob?
Negative 5x.
Yeah, negative 5x. Remember to keep that negative sign. All right. We need to get rid of that 5. What do we do, Tyson? Add, subtract, multiply, or divide? What do you think? Take a guess. 1 out of 4.
Divide.
You're right. Right? So you divide by 5 and the negative sign as well. Right? Thank you, Tyson. Put you on the spot there. Those go away. And it's not wrong to leave the negative on the bottom, but just not the preferred method. So you leave the negative to the top or put it out in front of the fraction. Either way, right? That's it. Okay? The next level of difficulty is a question like this. Right? So now we have a fraction. We go through the same steps. We split at the equal sign. What do we get rid of first? The 5 or the 3 and 2? The 5. Adding and subtracting 1, right? So it's minus 5. Opposite of minus 5 is add 5. Here and here. The 5's go away. We're left with 3x over 2. The other side, we have 9 plus 5, which is 14. Okay. So now I'm hoping you remember this kind of question from day 1. At this point, there is 2 things you could do. You could get rid of the 3 and the 2 in 2 steps, 1 number at a time, or you get rid of it all in one go. All right? I'm wondering if I should do both ways or just one way. I don't know. So I know in this class people prefer to do it both ways. Okay, let's try to do it the quickest way. If I want to get rid of the 3 and the 2 in one step. Yeah. Oh, hold on. Okay, so yes, horse here. Yeah, 2 on the top, 3 on the bottom. Remember, a number on the top cancels a number on the bottom, right? So if you do 2 over 3 on this side, timesing, you have to do the same thing over here. And if it helps, you draw a little imaginary 1, right? And you go, 2's cancel out, the 3's cancel out, you're left with the x. On the other side, you do your multiplications. 14 times 2 is 28. 1 times 3 is 3. 28 over 3 is our answer. That's it. Okay? I won't do the other question there, but I know there were some people who preferred to do it in 2 steps. So I'm going to do that right here. If you're happy with this step, this is probably what you're going to do in grade 10, so stick with this. But otherwise, here's how you do the other ways. So if you wanted it in 2 steps, remember I said usually it's easier to get rid of the denominator first. So we're dividing by 2. So opposite of dividing by 2 is to multiply by 2. So if you wanted to do it in 2 steps, you go times 2, times 2. The 2's go away. You're left with a 3x equals 14 times 2, which is 28. Right? Then you go, oh, I want to get rid of the 3. That's multiplying. So I divide by 3, divide by 3. 28 over 3. Okay? Still the same answer. Some of you guys find this easier. Some of you guys find that easier. To me, it doesn't make a difference. You pick the method that works for you. Now for the word problems. These are the ones probably you're going to find the most frustrating. Because I can't just tell you how it always works like this. Up to now, it's sort of been like this. Like, hey, it always follows some sort of pattern. It's always like this. But now, there's lots of different questions they can give you. And you really just need to understand the question. I'll do my best to generalize it. Okay? So one type of question that they're going to give you, it'll be involving shapes. So most likely perimeter or area. So you need to know those 2 formulas. So we're going to do a shape question here first. Here it says we have a isosceles triangle. All right? So a isosceles triangle means we have a triangle where two of the sides are the same. Right? That's what this is saying. It says the perimeter of this triangle is 50.6 centimeters. Okay? That means the distance all the way around. If you add up all the sides, going all the way around, it would be 50.6 centimeters. Right? It says this triangle has one short side and two long sides. So that means these are the long sides, and this must be the short side. And they said the short side is 10.8. It says, come up with an equation and solve this. Now, honestly, if you can just come up with the answer, which most of you guys probably could, I'd be fine with that. Your next year's teacher might be like, hey, I do definitely want to see an equation, right? And we'll do it both ways, okay? So, if we don't know what this is, all right, we know that two of these plus that short side must be the distance all the way around. So that is our equation. Right? Now, before we go to solve this equation, can somebody figure out the answer to this one without using the equation? Do you know what steps you would do? Right? I think I could give this to a grade 7 student who's been working with triangles and figure it out. If I was teaching this in a junior class, what we would do is like, I'd start off with like, okay, if the distance all the way around is 50.6, and I take away this, that must be the distance here. So I go 50.6, take away 10.8. That means that both of these are 39.8. Does that make sense? Then how big must one of those be? What would you do? If both divided by 2, because they're both equal. You go divide by 2, that means each side is 19.9. Right? So if you go 19.9 plus 19.9 plus 10.8, you get the answer. Right? And I think most kids, like I put you guys on the spot, but most people could probably figure that out without an equation if you give enough time. Okay, so now let's go through the equation. All right, so we go like this. We have our perimeter equation set up, right? Cover up the side that doesn't have the letter. Which number do we get rid of first? The 2 or the 10.8? Yeah, the adding and subtracting one. That's plus. So we go subtract 10.8. Subtract 10.8. The 10.8s go away. You go 50.6 minus 10.8. So I go 50.6 minus 10.8. Yeah, 39.8. Right? Then we want to solve for x, so we need to get rid of that 2. How do we get rid of that 2? Divide by 2. Divide by 2. Half of that. 39.8. Divide by 2. Look at my screen. It's the exact same order as before. Like, I know when we're writing these algebra things down, it looks very abstract. I'm hoping, maybe a big ask for by the end of this year, but at one point, hopefully in your math career, you can sort of see that these two things are the same and it clicks for you in your mind, right? The order we put all these things in the calculator are identical, right? And it should be, right? Because we're talking about the same thing, right? So for purposes of grade 9, I'm just happy that you can solve this equation. Or solve the problem. Whether or not you come up with an equation, that's irrelevant to me. All right, right now I'm working on your problem solving skills. So whether you set up an equation or you draw me a diagram and you show me the steps that you did, that's fine as well, okay? Because both of them are doing the same thing. All right. The last one. Then the rest of the class working on your assignment. Okay, so one question will be either about shapes. The other one will be a word count. And this is like a very standard grade 10 question. That's going to look like. This is what the difficulty of the create your own equation in grade 10 will look like. Here it goes. I'll paraphrase this. All right. We're renting a banquet hall. All right. We have a budget of $2,800 in change here. Right? We just want to find out how many guests we can invite. So we go to the banquet hall. The manager is Nick. Nick goes to us. Well, here's my pricing. Right? You can have the room for $215. That's the cost for the room. Right? But I'm also going to charge you $27.50 per head. So that's to cover the cost of the food. Right? Food and stuff, each person is $27.50. Right? So our task here is to figure out how many people can we invite to our party. Right? So you can probably do this without an equation. Well, let's create an equation. This is a very standard thing you're going to have to do. Right? So we want to figure out our cost. Right? It comes in two parts. Right? We have the cost of the room plus a cost that changes depending on how many people we invite. So that's $27.50 a person, right? So if we just invite a lonely party of one person, it'll be $215 plus $27.50. If we invite two people, it'll be double that. If it's three people, it'll be triple that. Right now, we're trying to figure out how many people we can invite. So we don't know how many people they're going to be. So saying, instead of having a number there, we're going to put down a letter. I'm going to put down P for people. Right? So if it's three people, we would triple it. If four people, we would quadruple it. Right? And that's the equation we want to solve for. So right now, our budget is this much money. Right? So we're going to see if that's enough money to invite the people we want to invite. So our total cost has to be under $2,800. So I'm going to replace that for money. There we go. There we go. So that is our equation we want to solve. Right? So we split this at the equal sign like this. Cover up the side like this. You go, okay, which number do we want to get rid of first? The 215 or the 2750? 215. We're adding 215. So the opposite of adding is subtracting. So negative 215 here, negative 215. We subtract these two things. All right. So you have 2780 minus 215. We get $2,612.80. 2612.80 2750 person. Okay, and we divide that by 2. Oh, not divided by 2. They divide it by 2750. We just want to figure out the people. 2750 gone from here, and 2750 gone from here. We just have P. And we write a sentence of how many people we can have. So I go that divided by 2750, and we can invite 95.01. All right. So we made up a number for our budget. We can't, the math says we can invite 95.01 people, but we can't really invite 0.01 people, so we can say we can invite 95 people, right? Right? We can't round that up to 96 because we don't have the budget for 96. We can have a party of 95 people, right? Because the people are whole numbers. That's it. So now, I said this is a very stereotypical question because there's lots of different scenarios I can give you. It could be a question about, oh, you take your car into the shop and there's a cost for the shop rate. Oh, the mechanic charges $60 an hour plus the cost of the parts. When you create any of your formulas in grade 9 and grade 10, it's going to look like this. You'll have a number plus something that changes, like this, right? It's always going to look like that. That's the only consistent thing they can do that. Now that's the type of formulas you're supposed to be working in grade 9 and grade 10. So that's the only clue I can give you, all right? It's going to look something like that, all right? Okay.